Welcome to the deep dive. Today we're navigating a really fascinating topic, the absolute cutting edge of industrial IoT, and specifically this quest for truly self-configurable automation systems. We've been looking through some incredible insights, mostly from an Eclipse Insight event, but also some detailed documents. They really break down how industrial systems are getting smarter, more adaptable. It's pretty revolutionary stuff.
That's right. And our mission today really is to unpack how these industrial processes are fundamentally changing, moving beyond those older, more static systems. We'll try to cut through some of the complexity, highlight what's genuinely surprising and impactful for you. Give you a bit of a shortcut to understanding where manufacturing is heading, like right now.
And trust me, you're going to want to hear this. We're exploring research from, well, a leading institute focused on software-intensive systems. We're also diving into some crucial open-source software that's really driving this change. And ultimately, we're sort of peering into the future of, well, maybe genuinely autonomous factory floors. So let's dive in. Okay, so when we talk industrial automation, for a long time, the picture was this rigid automation pyramid. You had these very distinct layers. Down at the bottom, PLCs, programmable logic controllers, these are the real workhorses, right? Built for tough environments, dust, vibration, humidity, all that.
Absolutely. Really rugged.
And they come in different types, too, soft PLCs, micro, compact, modular ones. And for decades, the way you programmed them often was using these things called function block networks, kind of like building with digital Lego blocks.
Yeah, very structured.
Then, as you went up the pyramid, you had HMI, the human-machine interface for the operators on the floor, then SCADA for supervising and gathering data, MES, manufacturing execution systems, managing the actual production process, and right at the very top, ERP, handling the overall business side. It was, well, very hierarchical.
And what's truly fascinating now, and what the sources really emphasize, is how Industry 4.0 is just fundamentally shaking that up. We're moving towards something quite different. The sources talk a lot about higher interconnection, definitely rising complexity, and this really dramatic shift away from those strict hierarchies towards genuinely distributed systems. And that transition, that move, is precisely why adaptability isn't just nice anymore. It's become absolutely critical.
So thinking bigger picture then, what does this rising complexity actually mean for businesses on the ground? Why is it such a challenge? Why does it demand totally new solutions getting away from that old pyramid model?
Well, it means the old way of doing things, manually configuring and then reconfiguring every single little piece of a complex system. It just doesn't scale. It can't keep up. Imagine like trying to manually retune a whole orchestra every single time a new musician joins or they switch songs.
Okay, yeah, impractical.
Exactly. That's the kind of bottleneck we're talking about. This rising complexity in these interconnected distributed systems. It creates huge delays. It makes businesses less agile. And, ultimately it stifles innovation. And that's why these new adaptable solutions are so vital. They let a factory floor actually stay nimble, react quickly.
That really paints a picture of the scale, doesn't it? This complexity and the need to break free from the old model. It demands serious brain power, which I suppose is exactly where an institute like Fortis comes in. Their official title is the Research Institute of the Free State of Bavaria for Software-Intensive Systems and Services. Quite a mouthful.
It is. Well, what's really interesting about Fortis is its structure. It's nonprofit, but it has this strong public-private element. The Free State of Bavaria and the Fraunhofer Gesellschaft are the proprietors, and it's also affiliated as an independent institute of the Technical University of Munich. So that blend gives them this really powerful academic footing, but they stay very focused on application.
Right.
They're kind of uniquely positioned to take cutting-edge theory and actually translate it into real industrial solutions.
And they're not small scale operating out of Munich. We're talking, what, 170 employees?
Yep.
60 active research projects, 150 current research partners. That's significant. It means they can actually bridge that gap between pure research and what happens on the factory floor. They're fast-tracking the future, essentially.
Exactly. Their core work is research, development, and crucially, transfer projects. These projects literally form the basis for new products, new services, new business models for industry. They do both publicly funded work and direct projects with companies. Basically, they handle the fundamental and the applied R&D for software, systems, service engineering. The stuff companies build on top of.
Okay, and this next part will probably resonate with some of our listeners, especially developers. Fortis isn't just researching behind closed doors, they're making major contributions to open source software.
That's a key point.
Yeah, they have projects like Autofocus, that's a building kit, like software tools for embedded systems. Then there's Fortiac,
Yeah.
that focuses on improving code quality in industrial automation, methods and tools for that.
Hmm.
And even a robotics library, a C++ library for things like robot movement, planning, control. And these are under familiar licenses, right? Apache, Eclipse, BSD, stuff people use.
Widely used, yeah. Makes
Mhm.
it accessible.
And it was actually Fortis, their Industry 4.0 team, that was presenting at that Eclipse Insight event we mentioned, talking about this very topic, on the way to self-configurable automation systems.
Right. So let's really unpack that core idea, self-configurable automation systems.
Hmm.
What's so fascinating and why it's seen as the next big leap is that it directly tackles that rising complexity we talked about, the complexity of these distributed systems in Industry 4.0. It allows systems to adapt autonomously without someone needing to step in manually all the time. Imagine an industrial setup that can literally, well, reorchestrate itself based on changing needs.
That sounds incredibly powerful, almost like science fiction, but it's happening. So what technical bits and pieces, what capabilities do you actually need to make that happen? How do you build a system smart enough for self-configuration?
That's a great question, and the sources are pretty clear on the shopping list, so to speak. To get this self-configuration, systems need to be, well, incredibly smart and flexible, almost like a living thing. They need a modular software structure, so parts can be swapped out easily. They need the ability to dynamically load new types of code while adapting their programming on the fly.
Okay.
And they need to handle different software versions smoothly, version management right there on the runtime environment, plus automatic network configuration. They need to figure out the network themselves.
Right. Makes sense.
And then beyond that, they need to be able to reconfigure themselves while operating. So online reconfiguration.
Wow.
They have to automatically discover new devices that pop up on the network, understand what software applications are already running on those devices, and even connect this idea of a digital twin for each piece of equipment, what's called an asset administration shell, or AS. That tells the system the device's capabilities, what resources it has available.
No.
Yeah, it's quite a list. It's this complex dance where the system gathers all this info and then calculates, okay, what's a valid way to deploy this application given the resources I have on these PLCs?
Okay, so if these systems are going to be reconfiguring themselves, they must need like a common language to talk to each other, right? Is that where something like the IEC 61499 standard comes in? Is that the foundation?
Precisely. You hit the nail on the head. IEC 61499 is absolutely foundational here. Think of it as the universal grammar, the shared vocabulary for these distributed systems. It's described as a domain-specific language for distributed control systems, and importantly, it's event-based.
Event-based, meaning...
Meaning components react to specific events happening rather than just rigidly following a step-by-step program line by line. Much more dynamic. And crucially, the standard defines how devices are configured using management commands and a standard exchange format. It uses concepts like the application model, the system model, device and network interfaces, process interfaces, and of course, those function blocks we mentioned earlier, FB1, FB2, FB3, those modular building blocks.
Okay, so the standard sets the rules, and then Eclipse Fortiac is like the toolkit for actually using those rules.
Okay.
How does it make IEC 61499 practical?
Exactly. Eclipse Fortiac is the practical engine room, if you will. It has two main parts, Fortiacide, the integrated development environment, that's where you design the system, and Fortiac Forte, which is the runtime environment. That's the software that actually runs on the PLCs and controllers out on the floor.
Got it. Design and execute.
Right. And together, they handle deploying the application code that's generated for these specific function block types. It knows how to target specific compilers, generate the platform-specific code needed for all the different kinds of devices you might have. It's the bridge from your design straight to making it run on the hardware.
Okay, that helps connect the dots. And to make this even more concrete, the sources talk about a demonstrator concept. It sounds like an example where a development PC using Fortiac IDE manages a situation where there's a missing automation project, and it achieves automatic reconfiguration using these function blocks FB1, FB2, FB3. It gives you a real sense of how these pieces actually solve a problem automatically.
Yeah, and building on that, there's also the discovery demonstrator, which shows another key piece. It illustrates how Fortiac Guide can use something called JMDNS.
Yeah.
It's a service discovery protocol, basically a way to find things on a network. It sends out a simple query like, hey, any Fortiac Forte devices out there?
Broadcasts it.
Yep, any Fortiac Forte there. And then it listens for responses. You might get replies from a CE/CD controller, an MRX industrial router, maybe an Embrick RevPi, different devices on the network. And the responses tell it, yes, I'm here at this IP address, maybe 10.20 or zero point 0.4, 0.107 or 0.118 or 0.125. And critically, they also list the function blocks they have available. So this demonstrates that crucial capability, the system automatically finding, identifying, and understanding what resources are available on its network, all without needing someone to manually list everything.
And what really hits home for me looking at all this is just the sheer scale of the change we're talking about. Industrial processes becoming truly dynamic, adapting, evolving without needing manual intervention for every little change. Imagine no more stopping a whole production line just because you need to switch to a different product or demand shifts slightly.
Exactly. That's the real aha moment, I think.
Yeah.
The vision here is industrial systems that can genuinely adapt and reconfigure themselves, on the fly. This isn't just making things a bit better, it's a fundamental shift. It cuts down manual work, boosts efficiency dramatically, and honestly, it probably opens up totally new ways of producing things that we haven't even thought of yet.
So quite a journey we've taken. From that rigid automation pyramid to this complex, interconnected world of Industry 4.0, powered by research from places like Fortis and open source tools like Fortiac enabling it, all heading towards these truly self-configurable systems. So the final thought for you, our listener. What does all this actually mean for the future of manufacturing? Imagine a factory floor that can literally redesign its own workflows in real time based on what it needs right now. What new possibilities, or maybe even new challenges, does that spark for you?